Hi, how are you? And welcome to another one of my episodes. The last time I left saying that by matter occupying time-space, it ends up creating a certain type of situation. So I'm going to get into that in another episode, because I remember that when I was explaining to you how the universe is oval in shape, I didn't quite went all the way with it. I should have, but I don't like to leave things in pieces. I will get back to that later on once we go into other areas of physics, like relativity and many other areas. But I had to finish this because it's not completely done yet. And so before I teach you how gravity is, it's better to do this because it's not finished until I do it. So it's when I was talking about the universe in the first episode, the universe being oval in shape, and why was it oval in shape? I should have also told you why the universe accelerates, because since it's already there, and remember that I told you that once I found the theory of gravitation, or gravity actually was, that everything, all the pieces started fitting in. With this and this part is also the same thing. The pieces just fly right into the picture. So right now I'm going to teach you why the universe accelerates. Because of relativity, you would think, well, after the Big Bang, the universe should continue to expand in the same exact speed and not change. Some physicists wanted to, instead of changing because of cooling for some reason, they say cooling, or gravity, because of the universe gravities, it should start to slow down a little bit and go back. But it's actually accelerating, and there's a really good reason for that. And the reason for that is that think of the dark collapsed star. By the way, from I like to say dark collapsed star instead of black holes, because it really explains what it is. Black holes was given the name black holes when physicists didn't know exactly what it was, and they thought it was a hole in space that you went through and ended up in a different universe, and it's not that. It's a star that became supernova, and it collapsed to its ultimate state, creating nothingness and a universe inside it. So it is a dark collapsed star, and it should probably be called dark collapsed spinning star, because they are the fastest spinning objects in the universe. Because they go from, like a ballerina, they go from a very large state to a very small state. It's like a ballerina just pushing her hands down like that and going really fast. Except a lot, it's like a ballerina going like that and then turning into a little thing like this. So it spins even faster. Okay, so because of that, it should be called dark collapsed spinning star. Plus, it's fun. It's fun. Black hole, and we have this notion about physics, like black holes and Uranus and things like that. You don't think of physics. It's better to call it. You gotta call it a black hole, or you gotta call it a dark collapsed star. Dark collapsed star sounds so much cooler, and it sounds like a science fiction, from some sort of science fiction movie, like Empire Strikes Back or something like that. And it's actually the way we should call it, because that's what it is. And so anyways, I gotta teach you right now why is it that the universe is actually accelerating outward. And it's because, if you look at a dark collapsed star, it is basically in oval shape because it's spinning very fast, but it is also a ball of time and space. It's a ball of time and space. And if you see that it's a ball of time and space, you're going to find out that because it's a ball of time and space, from the inside out, it has small, space-time on the inside, and as it goes towards the outside, the space-time becomes wider and wider. Okay, so on the inside, there's a time dilation related to the outside. The outside, the more outside you go, the more time-space expands. So you have a ball of space-time, and it's a distorted space-time because in the center, time-space is small, and it goes, wider and wider. So it is, if you can see it as a piece of pie, the space-time inside the dark collapsed star, it would be like that, okay, like this. And what happens when you have a time-space, or what I call already time-space when it comes to a matter? But in this time, matter is not the one creating the distortion. Is just time-space itself is distorted. So if it's like that, if time-space is distorted like that, if you see my past episodes, when time-space is distorted like that, what happens is a distortion already time-space, which means time-space tries to balance itself by flowing from the end that is the closest one towards the outside. So the universe, because it's a time-space that is distorted, it has an acceleration factor going outward. So because time-space is here and time-space is longer here, you get an acceleration factor that's going outward. So when the Big Bang appears and the matter and the universe appears, it also finds itself in a process of acceleration. So it starts accelerating outward. Okay, so that's bad news, because that's like a train. Okay, see a train, and the train just lost some part of the system, and it started to accelerate faster and faster, and it's heading to this brick wall, and everybody starts to panic. However, that's the bad news. Here's the good news. Okay, the good news is that because there's time dilation and time expansion. Okay, you have to know about time dilation is time going slow, but time expansion is what? Time going faster. So as the universe travels to the outside, it's accelerating towards the outside of the matter, in the universe. It's accelerating towards the outside. It is getting towards a wider and wider area of time space. So time space is actually expanding. Because time space is expanding, if you can put a tiny little clock in the center of the universe, one clock here, another clock here, another clock here, another clock here, and the last clock in the outside, in the edge of the sphere of the dark collapsed star, on the inside, time over here will be slow, over here will be faster, and the time over here is so fast you wouldn't even see the little hands of the clock. So even though we are heading outside and we are accelerating, which is bad news, the good news is as we accelerate, we have more time to survive. So it's like if a train is accelerating, and you see the train from far away and it's accelerating, and it's going to head to its doom, but you have a telescope and you see the train, and as the train accelerates more and more, you see a little clock in there in one of the windows, and the clock starts getting faster and faster and faster as the train starts accelerating. So you see people walking around, and you see people leaving, you see people getting old, dying, being born, and a whole bunch of stuff. And so you start looking at it and go, whoa, well, okay. And then it starts getting faster and faster, and it's about to hit the wall. And before it hits the wall, you look at it, and there's apparently there's no life in there. People live, die, they live all their lives, and then they something happened to life because hundreds of years or something, whatever, and there's no life anymore. Nobody lives there anymore, and it just ended up crashing against the walls. So that's the good news. The good news, that's just like the news. The good news is, even though time space is wider, and that causes an opposite, a gravitational force that goes from the inside of the dark collapsed star out. So the universe starts accelerating outward. At the same time, that the universe is accelerating outward, when we see the universe accelerating, it's not accelerating it's accelerating faster than the way we perceive it. It's accelerating faster than the way we perceive it, because we are perceiving the universe accelerating as time-space gets wider. So instead of time dilation, we have the opposite. Okay, so because of that, time-space gets faster and faster, and when we perceive the accelerating universe, it's not accelerating to us as fast as it would be accelerating if we were looking on the outside, where time-space doesn't change at all. If we were looking on the outside where time-space doesn't change at all, we will see a big difference. We see the universe accelerating faster, because we wouldn't be attached to the time expansion that we attached to. So I just wanted to say that that's the reason why the universe is accelerating, which is bad news. But the good news is we have a very long time to do whatever we like, because the universe is gonna last a very long time, because the further away we move, the faster time goes. And I guess that will be the end of this episode. In my next episode, I'm going to get deep into relativity, because we need to get deep into relativity, because nobody anywhere gets deep into relativity, because when we do, we find scientists find anomalies, and you can have anomaly in a theory. If you have anomaly in a theory, there's something wrong. You are doing something wrong. So, in one way, we talk about relativity, and we talk about it in the right way, but then it's that we cannot believe in what we are saying, so we use our instinctive minds. Remember what I told you, that the mind doesn't see reality, it sees the perspective of reality. So we start talking with the perspective of reality. Even though motion is reality, we start talking about speed like if it was a big deal, and the speed is not a big deal, because this speed is relative, because motion is relative. Speed is a different word for motion. So I mean, if we stay in motion is relative, we stay in that area, we are going to learn a lot more than we are learning now, because now we're saying motion is relative, but we don't dare to get really deep in it, because our mind tells us something else, and when our mind tells us something else, we start putting walls and what do you call barriers and stuff like that. So anyways, so my next one will be about relativity, and just to give you a little taste of what I'm going to talk about. When it comes to relativity, if you are in space and you are let's say you were on a spacecraft, but the thrusters are off, okay, there's no acceleration factor there, you are standing still. Okay, you're standing still, and guess what? Your direction is whatever object passes by. Okay, in other ways, you are standing still, all right, but you are going at different directions and at different speeds relative to some other objects. Okay, that is basically what motion is. Motion is relative, and this hasn't been. I don't think this has been taught to you, because every time we talk about relativity, we talk about relativity on planet Earth, like going through a road and another car passing by and stuff like that. But we never get deep into relativity, like going into space and just standing there, stillness. Because relativity is when you're standing still, it's like you are in an island of still motion space. Okay, it's an island of still motion space, and other objects are also in their own island of still motion space that are different than yours, and that difference is what makes is what makes the motion. But because we are both standing still, the motion is relative to the other object, and the motion is always exactly the same. So if this object passes by you at 50 miles an hour, To this object, it is us that we are going that way at 50 miles an hour, and to us is this object that is going at 50 miles an hour that way. Okay, so that's what I'm going to give you a taste of. The next time we're going to get really deep into this, because I don't think anybody had gotten deep into this before, and you need to realize what relativity is before you could possibly ever learn about what gravity is. Because if you don't have a good foundation of that, you don't know what gravity is. And even though I explained gravity before, for some of you guys maybe already know what gravity is because you got the hint and you put all the puzzles together, but for all the people who didn't, it's good to have a good knowledge of what relativity is, so that then when I explain relative time-space and how it shrinks when you accelerate, you are able to understand and view the collapse and the distortion of relative time-space that happens when objects accelerate and when objects travel in a circle, and when matter occupies space and time. Okay, so I leave you guys here. I hope I didn't. This video wasn't that long, I hope. Anyways, so my next video, I will hopefully explain all that for you guys. Right. Take care.